Welcome back to this cool tutorial about a Twitter-like app built completely with Swift and with support of the cool Parse backend. And in the last tutorial, we have created a user interface for our app. The final result is going to look something like that. We already have our table view, we have our segue, which transitions us from our timeline to our compose view controller. We have all the user interface elements in place. So now it's time to get started writing code. So I think it's best if we start within the compose view controller so that we can actually display something to our timeline. So let's open the compose view controller and get back to the standard code and give us some space here. And the first thing that I'm going to do is give our text view here a little border. So that it just looks a little nicer, and we will therefore use the sweet text view and use the layers of this text view, and say first we want a border color. Now this border color is going to be black, so let's call UI color black color. And because this is core graphics, we have to use CG color, a CG color reference. Now next, let's say that we want a border width of 0.5 pixels. So again, sweet text view layer dot border width equals 0.5. And this is supposed to be rounded. So let's give it a corner radius. Sweet text view dot layer dot border corner radius. This is going to be 5. And now it's just nice if the user is going to get his keyboard right when he enters this compose view controller. So let's just say sweet text view dot become first responder. This will call the keyboard as soon as we get to our compose view controller. Now let's just go back to the storyboard and remove this color here, background default, and see if this works. So there we have our text view with its nice rounded corners, and you also see the cursor in this text view. It seems that the keyboard doesn't appear in this version of Xcode beta, but on the device it's going to work. So let's go back to our code, compose view controller, and talk about the send sweet function. So what we actually have to do if we send a sweet is really easy. We have to create a PF object. And how you're going to do that, you can see in the documentation of Parse. So you select documentation, iOS, OS 10, and objects, and there you can see how easy it is to create an object. And we are going to use the Swift syntax, so check out this documentation if you need some more explanation. It's really easy, and you're going to see how easy it is just in a second. So let's create a PF object, which is called sweet, and we will create a class for that, which is called sweets. A class actually resembles to the to what you can see here. So all of this are classes. Every time you create a new class, you have a new table in database language. So we have now created a new table, which is called sweets, and there are going to be two columns within this table. Actually, the content of our suite and the person who sent it, the sweeter. So let's say suite brackets. The first one is content. This is going to be our suite text view .text. And then we will have to add our sweeter, suite brackets, sweeter. And this actually is going to be a user. And we not really have created a user yet, but Parse is going to support us here as well. So let me now just say pf user current user. This is going to place the current user logged into our app into this key sweeter. All right, now we have created our object and now we have to save it. So let's say suite.save in background, and this is going to send it to the database, and that's all there is to it actually. And we have to go back to our timeline view controller. So let's just call self.navigationcontroller.pop to root view controller, and we want this to be animated. So let's say true. And that's it. Now, as I said, we don't have a PF user yet. So if you have watched the first tutorial, you've seen that I have used a alert view, or as it is called now in iOS 8, an alert controller, as soon as the app starts. So let's go to the timeline table view controller into our viewDidLoad function. Or actually, it would be even better if we would use viewDidAppear function. So let's say view did appear, and I'm going to use view did appear because there are some things that we're going to do later that should occur as well when we return back from our Compose View controller, like reloading the table view and displaying the suite that we've just created in the Compose View controller. So let's write our code within view did appear, which is always called when the view actually appears. viewDidLoad is only called once when the app starts. So what we have to do now is check if there is already a user logged in. And this is really, really simple. All you have to do is write if pf user dot current user. And if this is the case, there is already a user. So let's invert that using an exclamation mark. So if there is no user at the moment, we are going to have to give our user the opportunity to either log in or sign up for our app. So let's create an alert controller for that, which is going to be called login alert. And this is going to be an UI alert controller. And let's call a convenience initializer, which is going to be UI alert controller. And we give it a title. Let's say sign up or log in. The message is going to be please sign up or log in. And our style is UI alert controller style alert, not action sheet. That's it. And now we have to give it two text fields, actually, one for the username, one for the password. And this is really cool. We can use loginalert.add text field with configuration handler. And we're going to use a closure syntax of Swift for that. So let's open curly braces. You just saw that we have to use, well, let me show you that again. We have to use a text field within our within this configuration handler. So we have to write text field in. You could call text field any way you want. It is automatically of type UI text field. So let's say there is going to be a placeholder, text field dot placeholder, which is going to be your username. And that's it for the first one. Let's copy that and paste it. And the second one is going to be your password. And the password should be secure. Password text field should be secure. So let's say text field dot secure text entry equals true. Well, that's it. Now we are going to add two actions. One action for login, one action for sign up. So let's say login alert dot add action. It's going to be an UI alert action with title login. Style is just default, UI alert action style dot default, and our handler. All right, not so cool. Default. Well, and actually our handler, there you see it, also requires a closure which is going to expect a alert action. So let's open our curly braces, give it an alert action in this closure, and what we are going to do now is we have to distinguish between our two text fields, and we then have to log in this case, the user with its username and its password. So how are we going to get our two text fields? Let's just build that. Build failed. Why did that fail? Your alert action style title login style, your alert action style dot, this must be a uppercase D. All right. So now we will create a constant, say text fields, and this is going to be an array, NS array. And in this array, we are going to store all text fields within our alert controller. So let's call our ask our login alert for its text fields and cast them to an NS array. And now we have an array with two text fields in it. And now we can just say, well, there is an email, username text field, username text field, which is a UI text field. And this is at the top, because we define it that way. So this is text fields dot object at index 0. And we'll just cast that to a UI text field as well. And now let's do the same for the password. Password text field is going to be a UI text field equals text fields object at index. And this is of course 1 because it's the second one we defined. So also cast that to a UI text field. And now we can use parse again and really easy say pf user login with username and password. And the username is user name text field dot text, and the password is password text field dot text, of course. And now this gives us actually a completion handler which was not displayed within the code completion. So let's write this completion handler ourselves, opening some curly braces here, and using the closure syntax of Swift. And this gives us actually a user, PS user, we'll unwrap this right now, and also an error, NS error, and it returns void in this closure. And now we can actually check. Why is this not working? Because I have not said I want to do this in background. All right. Username text field. All right, login with username in background. And here in this closure, we can actually check if there was an error or if a user actually has been logged in. So if there is a user logged in, We can say print line login successful, else login failed. You could do some nice fancy stuff here if you want, prompt another alert view or anything, or display something within a label. But for the sake of our tutorial, this is going to do just fine. And now let's do the same thing for a sign up, which is going to be a little more complicated, but we can still copy this this add action function here, and let's see, this is the action, so I have to copy until right there. All right, so this is going to be our sign up button. So let's say sign up. We also need those two text fields. We can, however, remove this PF user login. What we will use instead is we are going to create a new user object, which is going to be called user. We could also call it sweeter PF, which is of object PF user. We'll initialize it as a PF user, and now we can give it its username. So sweeter dot username is going to be our username text field dot text, and the sweeter's password is going to be password text field dot text. That's it. And now we can say sweeter sign up with block. All right, and we can now just remove those parentheses and write some curly braces and do this in a closure. And we also get from Parse a success message, which is of type bool, and we also get an error, which is an NS error. We will unwrap both of these to use them directly within our code, and this returns nothing, and that should actually do it. Yes. And if there was no error, then we can say, yeah, print line sign up successful, or else we could also show the error that really occurred. So let's create a constant error string equals error dot user info. We will use the error that is placed into the user info and convert it to a string, and then just print the error string. All right, build succeeded. And now if we run our application, we should see, oh no, we shouldn't. We first have to present our alert controller. So let's say self present view controller, and we will present our login alert, animated true, and with no completion blocks, so just type in nil. And now we can run it, and we're prompted with this great alert view. We have our two text fields, and let me enter let's say sweeter 1 password 123 and say sign up. We get our sign up successful message, and if we now take a look at Parse and reload the backend, we should see a new class here which is called users, our user, and there we have our sweeter. Nice. So when we now run this application again, we shouldn't see actually this message again, because we have checked if there is a user already existing. So what we can do now is actually also check if our Compose View Controller is already working, because now we have a PF user and we can store this, this user within our suite objects. So let's try this as well. So let's enter a message, say done. It uploaded it, and if we now reload the backend, we should also see our suites. Yes, and there it is, the content we just typed, and there is our suiter, and when we just click on him, then you see we will be redirected to our user classes, and we can see that this suite was actually created by suiter1. Now, it's time to display all this stuff in our timeline. How are we going to do that? Now, the timeline view controller is, as you know, a table view controller. So we have to use some of the table view controller functions to achieve something here. And there are basically three functions that we're going to use. There's number of sections in table view, there is table view number of rows in section, and there is this one, which is still unused. And we have, I would say, first get rid of these errors here and do a comment here and a comment there. And let's talk about number of sections in table view. This is going to be 1 because we only have one section. A section is something like the headers of your address book when you use the address book app on your iPhone. There you have A, B, C, and all of these all of your contacts are sorted into these sections. So we only have one section, and our number of rows actually is how many suites there are in the database. So let's return 0 here for now, and actually it was a bad idea to uncomment that already, because we first have to get first have to know how many rows actually we can display. So let's go to the top of our class and write a new function. We will call this just function load data. And what we are going to do here is loading everything, all the suites from our database. So we have to start them somewhere. So let's create an array for that purpose. So let's do it at the top of our class and call it timeline data. It's going to be an NSMutable array, and initialize it with NSMutable array, and that's it. So now, every time we load data, we want to get rid of all of that what's already stored. So let's say timeline data remove all objects, because when we return from our detail view controller, our Compose view controller, we want all of our suites to be displayed in the timeline, but because we have to add all the objects one by one, we first have to remove all the objects so that we do not add all objects to the list, and that all over again every time we reload our timeline. So we will now query through our Parse database and search for all suites. So actually we will say that we want all objects stored within this class suites. This is really easy. We can just define a query, let's call it find timeline data, and this is a PF query, and we will initialize it with a class name and say suites. And you could actually refine this search or this query by using some where statements, but we do not need that for our tutorial. If you want to know more about that, check out the documentation. It's really helpful when you want to know how you are actually going to select only a bunch of objects from your table. But we will later also do a little where statement so that you can see how this actually works. So now we have to find our query, and we can now just say find timeline data dot find objects in background with block. And what we do here is this is all done asynchronously. So we can now within our block get objects of type any object first. This is an array. Unwrap it, error, NS error, unwrap this, returns void in. So now we have done all the necessary steps to define our block here, and we get from Parse, when we run this this query in background, we get a bunch of objects within an array. So now if there was no error occurred, then we can iterate through this array of objects and add this to our timeline data. So let's say for object, which is going to be a PF object, because PF objects are stored within the within this array. So for object, PF object in objects, what we are going to do is say self.timeline-data.add object. Let's run this. It failed because we have to unwrap PF object first, because we are within this closure. So now if this is done and we have our timeline data full of suites, let's say that we want to reverse all of these suites because we want something like Twitter, and they are at the moment sorted from sorted by date. So let's say let array is going to be an NS array, and now we will just copy our timeline data into this array and reverse and call reverse object enumerator and say all objects. This will reverse all the objects, and they will now be the newest one will be at the top, and that's actually exactly what we want. So say self.timeline-data equals array as NS mutable array, because this is an NS mutable array and we just use an NS array. And now we can say self.tableview reload data, and this reloads our whole table view. And now actually we know how many objects there are, and so we can say how many number of rows in section there are in our table view. So let's say return timeline data dot count. This gives us the number of elements stored in our timeline data array, and the number of elements in our array is equal to the number of rows that we're going to need. So now I can finally uncomment the self-row at index path function here, and what we do now is creating our cells. And before we do that, actually, we must recheck if we already have defined the outlets. I don't think so, no. So we go back to the storyboard, click on our table view cell, and click on the assistant editor. And now we do not get actually the correct Swift file, so we will just select manual Swiffer app, and we want our sweet table view cell. And now let's begin with this label. This is going to be the username label. Then we have a timestamp label, and we have our sweet text view. All right. Now we have all the outlets we need. We just have to initialize them. So let's say UI label. Could copy that actually. And there UI text view. Build. And it works. Nice. So now we can go back to our timeline table view controller. And we are not going to use a standard table view cell. So let's define that our cell is going to be of type suite table view cell. And as you can see, this UI table view is optional. So we will have to unwrap it here, or you can unwrap it here if you want. But I'm going to just unwrap it here. If you want to know more about optionals, watch the last tutorial about creating a simple to-do app. There I'm going to explain how you're going to use optionals in a cool way and why they are so useful within Swift. And actually we have to do the same thing here for index path. And we earlier in the last tutorial said that we have to use a reuse identifier because all the table view cells are reused and not completely stored in memory, and we have defined cell as our reuse identifier. And we still get an error because we have to cast this dequeued cell. We have to cast it to a suite table view cell. All right. Now, that's all there is to it for the moment. Now, we need to get the right suite to display in the right cell. Therefore, we are going to say let suite, so we've defined a constant here, let suite be a PF object, and now we will say self.timeline data and select object at index. And as I said, the rows are corresponding to the objects in our array, so we can just use our timeline data object at index and use the row of the current of the table view to identify the correct suite that we want to display. So this is going to be index path dot row, and again, because index path is optional, we have to unwrap it first. So index path dot row. Right, and we have to cast it to a PF object, and that should do it. Nice. Now we have a PF object, and this PF object actually contains all the data we need. So we let's start by adding some data to our text view. So let's say cell.suite text view, and this is suite.object for key, and now we can check in our backend, check the data browser and see, okay, we have an object from the suites class and we want the content, so we have to say object for key content. And we have to cast it to a string so that it is displayed correctly as string. And we have to call it text property here. And that's it. Now let's take a look and run it. And you see nothing because we haven't called our load data method yet. So let's do that. In view did appear. And say self dot load data. And now let's have a look. And there you see our first table view cell. We have our first suite in it. So if I go into our compose view controller, write another suite, here's my second suite, and Done. And then you can see that we have our second suite here. It is placed at the top because we have reversed the order of our objects. And now we have to still have to fill in the gaps. We have to place the username here. We have to place the timestamp here, and we also have to create this character count here. Well, now let's get first to the username. We're going to do this in our self-forward index path method, and therefore we will have to take a look at the data browser again. Because when you look at the at one suite object, then you can see that there is only a pointer to the user. So when we click on it, we get to the user, but actually there is only an object ID stored within this suite object. So what we have to do is run another query to get all the data we need. So how are we going to do that? Well, we just will define another query, find sweeter, as a PF query. And therefore, because we search for a user, we have to use pfuser.query. And now we will specify what user actually we are looking for. So we will say find sweeter where key is equal to. So the key, what we need, is going to be the object ID. We will search in the user class for a specific object ID. So let's say object ID is equal to the current suite, which is stored in our suite object, dot object for key sweeter. Have a look at it. The object ID is stored in sweeter, and we want the object ID of this object ID. So now we have defined our query. Now we can say find sweeter, find objects in background. You already know that. Just the same closure syntax as before. And the object, this is an array, unwrap it, error, NS error, unwrap this, returns nothing, void, so in. And now let's first check if there was no error. If there was no error, then we should have found exactly one user, because the object IDs must be unique. So we can define a PF user. This is a PF user, and we can get our object as an NS array. We use NS array because if we use NS array, only when we use NS array or mutable array, we get a method like last object. And we can say last object because we know that there can be only one object here. So when we say last object, we mean the only object that is actually stored in this array. Because as I said, there is only one user with this unique object ID. And let's cast it to a PF user object. So when we have found our user, then we can actually say, we have the user name label in our cell, and there we can call the text property and just say, well, user.username. Does it work? Yes. And that's actually it. That's it. Now, there is also the date missing, and therefore we will first create a date formatter, which is an NS date formatter, and just standard initialize it. and then we will give the date formatter a format, a date format, which is going to be the year, y, dash month, dash day, white space, hours, and minutes. Now that's our date format. And now let's say cell dot timestamp label dot text equals the date formatter dot string from date, and actually it's stored in our suite dot created add. That's really convenient. Now when we take a look at it, then we can already see that this should work, but we also see that that we should resize our label, and we should resize this label. We also should align this text maybe to the right, and also, because this is quite long, reduce the size a little, move it a bit to the left. And let's rerun the application. Oh, looks cool, doesn't it? But what you maybe have noticed is that because all of that stuff runs asynchronously, it doesn't look that well. So to make this a little cooler, let's work with some animations here. So before we let me just shift that a little, structure, shift right. So before we actually set text or anything, let's bring the sweet text views alpha to 0. Also cell dot timestamp label dot alpha equals 0, and also cell dot username label dot alpha equals 0. And when everything is loaded, actually we can also remove that comment here. When everything is loaded, we can do a little animation using UIView.animate with duration, let's say 0.5 seconds, and just a closure block with no parameters, and there we will say cell.sweetTextView.alpha equals 1, cell.timestamp label.alpha equals 1, and cell.username label.alpha equals 1. And now when we run this application again, it'll look a whole lot cooler. And it also gives this nice step-by-step view, because first this one is loaded and then this one, and you'll see when we return back, then we get the last one. Oh, I didn't click done. Yeah, then we get this cool asynchronous view transition and fade and cool animation stuff. Now, there are still some things that we have to do. For example, we still do not have the ability to see how many characters are remaining. So to do that, let's go back to the composed view controller, and what we need is actually the Uitextview Delegate. So let's use this Uitextview Delegate and have a look at the documentation for it. And the delegate method that we are going to need is should change characters in range, and there we have the Swift declaration for it. So let me just copy this method declaration and paste it right here. Open some curly braces, get rid of this unnecessary stuff, and just build to see if it works. No. Because we do not return anything, so let's return something here for the moment. Let's return true. And because we use a delegate, we have to say that our sweet text view also corresponds with this delegate. So let's say sweet text view dot delegate equals self, because self is, as you see, the delegate because we adopted it here. Now that we can check every time that the text changed, we can restrict the number of characters that are allowed, and we can also update our counter. So to do that, let's create a variable, call it new length of our text. It's going to be an integer. And now let's say that there is text in our text view. And we will cast this text to an NS string to be able to use the length property of NS string. And to this, we're going to add the text that is actually written, which is going the replacement text actually that is written, also cast it to an NS string, and use also the length of this string. Of the string class, and then subtract the length of the range, and that's it. Yes, and now we can calculate the remaining characters. So let's say remaining characters, and this is also an integer, and we will say we will going to have 140 characters, and we'll subtract the new length. All right. So now we can use our remaining character. No, that's not right. Let me just check how it's called. Characters remaining label. You can use the characters remaining label. Characters remaining label. It's text property, and then just use the Swift syntax to put some info to it, and this is going to be remaining characters, and there we have our calculated number of remaining characters directly within the text property of our label. Now, to actually make it stop being able to be editable, we will say, yeah, should this text view allow change text in range? Well, it should if there are less than 140 characters in it. So we will return new length if this is actually an if statement. So if new length is greater than 140, then we will return false. So you are not allowed anymore to change the text in range. So if not, so let's say true. So if there are less than 140 characters, return true and allow that text in range should be changeable or editable. And if we now run this, you will see that when we click plus and we write, then you see that the amount of available characters is dropping. So this is not that nice. So let's bring that a little to the left and type in 140. This should look a little nicer. And now the text view starts here. I don't understand that. I guess it's a bug. Well, okay, I'm going to ignore that for now. So we have this cool timeline now. We have the ability to add new suites to our timeline. So actually, all that's missing is the ability to see if someone else has used the app. We need the ability to reload it. So let's go to our timeline here and add another bar button item, place it here, and let's say refresh. And all we have to do now is go back to the automatic mode here, and then we have our load data function here. And now let's try to connect this button to our load data function, and you see it doesn't work. Well, all you have to do to make it work is put an add IB action in front of it. Now you can connect it to the using the interface builder or storyboards. So let's just connect it, and that's it. So if I were to write suites with another device, then I could just click reload now, and you see it always reloads when I click this reload button. Yeah, the last thing that's missing actually is a little user interface customization. Therefore, let's go to the app delegate class and add some just 2 lines at the top. Let's say UI navigation bar dot appearance dot bar tint color equals UI color dot orange color. This will just tint the bar color to orange, but we still have these blue buttons. So I think that white would look very good as a contrast. So let's say UI navigation bar dot appearance dot tint color, which is going to tint all the buttons in it. Say UI color white color. And that's it. Now we have a nice Twitter-like app. You could, of course, upgrade it with a bunch of great stuff. You could prevent it from reloading every time you go back from the Compose view controller, or you could add a way to reload the this in a more efficient way, not by reloading every time, but by reloading it every time you there is actually an update, and therefore you can actually also use Parse using push notifications. You would have to write some cloud code here, and this would definitely exceed the time that I have in this tutorial. So have fun trying some of these cool things with Swift and with Parse, and don't forget to look in the documentation even if there is something unclear, or if you want to come up with something yourself. There is a whole bunch of very, very useful documentation here. So get right into it, improve where you can, and don't be shy to tell me what you've done with this Twitter-like app, Swiffer. So have fun.